Hi everyone, this section is from one of my live streams where I explain the basic of bytes, bits and IP address using clear examples. I showed you how CIDR notation works and how to apply it effortlessly. So enjoy the video, guys. So guys, now networking. I told you that it's going to be the most important topic. I don't know why I let this topic at the end because my energy still needs to be up and it's quite hard. I'm not gonna lie. So, but don't worry, I have enough energy to finish this topic. I really love that one because at first I didn't like networking, but with time and just learning again and again those concepts, because you know the problem that you will get when learning new stuff is that you will go like this and then it go up. So it means that you will start to learn new concept, then here you will forget about this, you will forget about this concept. So you need to put energy, but less energy than here, you know, less energy than here, so you can gain back this knowledge that you forget and then reach another level and then again, etc. So until like when you hear, like you're really liking it, like you start to liking it because you're putting less efforts, you know, you're putting less efforts. And also the connection here is like better, like you feel, you start to connect, you know, things here and it start to make sense. So you start to say, oh, but actually, yeah, like I know why I learn about that, is because of this. So that's why now I start to like networking, and it's a journey. I'm not gonna lie, it's really a journey. So guys, networking, we are agree that is the foundation of modern IT. People said that it's the invisible bridge that connects devices, application and users in homes, businesses, and across all the world, all the globe. So that's why you need to understand key networking concepts, and it's what we're going to do. So we're going to start with bytes, bits, and the logical behind IP addresses. I will explain this one just like later. It's really going to make sense because everything lies to this. Then OC model, you will love the analogy that I have for you on this topic, followed by switches versus routers. Many people get confused about that. IP addressing and subnetting, networking topologies, and finally addressing the critical role of DNS in networking. This one is like just the fun, you know, like it's the end, so it's going to be only a small part, it's not going to be a big part. So yeah guys, so we're gonna cover a lot. I'm sure you will love it. So that's why each section will be tailored to help you understand not just the theory, okay, but also how it applies to real life scenarios, including my own lab setup. We'll see stuff on my own lab, and I'm gonna show you some stuff too. So what I want to do is to go, I can't, I want to go there. Yep. So what we will do is that we will delete everything here. We need to do this because it's a serious topic. This one is a very serious topic, and I want to show you things. I want to show you things there. So guys, what come at the heart of networking? At the heart of networking is data, okay? We are all agree on that. Networking is data, meaning it's only bits and bytes. Your computer only understand this. He only understand 0 and 1. He doesn't understand anything else. He doesn't understand your text message, the colors, the actual the actual video that you sent to your friend, the nothing. He understand none of this. None of this he could figure it out. The only thing he could figure it out is 0 and 1. It means that networking is only based on 0 and 1. And I need to cover this very fundamental concept because otherwise things could be like you would have some question, some interrogation about why is working that way, and especially with networking, you will see why. You will see why it's so much important to cover this very basic of 0 1 0 1 0 1 0 1 and then 1 byte, etc., and those combination. So a bit is the smallest unit of data, and it can be either a white it could be either a 0 or a 1. Okay, so let's represent by those 1. Where is it? Okay, so this bubble here is a bit, okay, and 1 bit is just a combination of either a 0 or a 1. What combination you could have with 1 bit? 1. Only 1. Either 2. It means either this light open, or either or either 2 of them are on. Okay, not open, sorry. 2 of them are on. So it means that here we have, let me use my pen. Here we have 2, because we have 2 combination. Either this is white, or either both of them are on. Okay, so it means you have 2 combination for 1 bit. Okay, sorry if I say byte just before, I don't know if I make the mistake, but no, 1 bit, 2 combination. 2 bit, 4 combination, because down here you have this, let's use those 4. For example, you have this combination, or for example, you could have, my bad, you could have this combination, or you could have, let's say here, you could have I already did it, so let's do this combination, and we can also have this combination, so it means 4 combination. And when you go until 8 bits, it means you have 256, if I'm not making any mistake, 256 combinations. It means that from, hold on guys, from 0, and by the way, 1 byte, it's 8 bits. So 8 bits here, this one here is 1 byte. We always put an uppercase for 1 byte and a small, I don't know how you call it, but a normal case for the bit. So, okay, when you have 1 2 3 6 1 2 3 6 1 2 3 4 1 2 3 4 5 6 7 and 8, here you have Okay, here everything is 0, right? You don't have anything. Now, the maximum combination that you could get to reach, sorry, it would be better if I do this way. Now, if we go to all the combination possible to reach this 1 1 1 1 1 1 1 8 times, it means that we went until 256 combination. For going to no combination and then going, so 0 bit 0 bit to 8 bits, so 1 byte, you went into 256 combination. So here I say 2-bit 4 combination. What is 3 bits? 3 bits is I don't want to make any mistake because it's live, and if I do any mistake, people will be mad. 3, it's 8. Okay? 3, it's 8. 4 bits, actually, sorry, 2 bits, 3 bits, 4 bits, it's, can someone, I'll let you think, and it's actually 16. It's 16 combination. And when you go, for example, let's say 7. Okay, no, I will continue. 5 bits, it's actually, and guys, to help you, you do 2 exponents, I think we say in English, exponent equal to 32. Okay, it's 32. And now when you say 6 bits, it's actually, we're gonna type it here, 64. Okay, 7 bits, so 64 combination. Okay, 64 combination. So from 0 bit to 6 bits, you have 64 combination. And then 7, you have 128 bits, and 8 bits, finally, you have a total of 256 combination. Okay? So it's very important that you know about this stuff, because otherwise it could be, it's really the foundation, guys. This thing you need to understand. You really need to understand this concept. So why I'm explaining this? I'm explaining this because IP address is only about that. It's only about that. It's only about, you have here, for example, my net. Sorry, I need to do this before. Oh, sorry. Okay. It's only IP address only about bits and bytes. What I mean by this is that, for example, my IP address is 192, 168, I forget, 57, and 19, for example. Okay, and here we say 32. I will explain you later why we say here 32. Okay, I'm not gonna explain it now. Why it's only about bits and bytes, I'm gonna explain it right now. Do you know what is the possibility of here? Why it's 192? Can it be, did you ever see a network that is 300, that starts with 300? No. Did you ever see a network that is minus something? No. You only see range from 0 to 255. That's a bit weird, right? It seems that it's 8 bits. And yeah, it's 8 bits. You actually got it. It's 8 bits. So it means you have 4 ranges, 4 section that are actually only that are 1 byte. So 8 bits. Here same. 1 byte. 8 bits. 1 byte, etc. 1 byte. So it means that all of the ranges here, all of the section could only be between 100 0 to 255 because it represents 256, and in IP address 0 counts, it counts. So that's why we say until 255. And in total you have how much bytes you have and how much bits you have. You have in total here 32 bits. So now we get why when you always see one device IP address with this notation. Now you get the point. We see 32 bits. We see 32 because it represents the total number of bits that is used in the network. Let me go for that. And what is CIDR notation and network address? So it's basically where your network is located. We need to know, like network engineer, they need to know where your network is located. And what is the range, okay? Because if someone come, of course the DHCP will send them an IP address. Like the network is living. The network is really living and is allocating resources, is giving IP to everybody that come to the network. So we need to locate this network address, and so when I talk about network engineer, it's because they are managing the network. They need, sorry, I just mute without purposes. I said, yeah, network engineer need to be aware of what's going on in your network. And the simple question that comes in first instance, where is your network located? So how we deal with this, it's simply by having this. I'm gonna show you right now. Here we have, for example, in my case and in VMware, you will see that it's called IP subnets. But in the working environment, it's not IP subnet, it's just network address. It's where your network is located, okay? But I don't know for what reason, but because it's isolated, then VMware in your virtual editor in here, I will show you if you want. View, edit, virtual network editor. He will told you subnet IP, okay? But it could be counterintuitive, and I will show you right now. Yep, I will show you right now. So look, you have here, where is my, hold on, let me take my pen. My network address is located here, okay? It's where my network it's, hold on, it's where my network is located. It's here, okay? So it means that by the way, it's the most important things. It's really the most important things what I'm going to do right now. and I'm gonna explain it later. So /24, it's the actual CITR notation, and the aim of this network here is to, like I said, locate the network and explain the IP ranges from where to where. What is the beginning of your IP address, and what is the last device that could enter your network? What is the finish line? So the finish line is, and I'm gonna explain it later why, it's from this 0, this is the beginning, okay, beginning, to 192, 168, 57, and because we count the 0 as we see before, until 255. And why we know this, why, for example, like if I see this, I will instantly say, okay, it goes from 0, it's the network starts from here, and it go from 0 to, it go from 0 here to 255 instantly. And how I know this, I will cover this right now. So from, look what we covered before. We said that here it's 8 bits, right? Not bytes. It's 1 byte. But by the way, let me check. Yep. 8 bits. Okay. Here, same 8 bits. Same 8 bits. 1 byte, 1 big byte, 1 big byte, and 1 big byte. And here it's 8 bits or not, because it's 0. It's still 8 bits, but you will understand what's going on. This one, from here, let me, from here to here, we have 8 exponent 3, which is, we have 3 8s. So if people don't like exponents, we will just write it like this. We have 8 multiplied by 8 multiplied by 8, which is, if you remember your math class, 24. 24 what? 24 bits. What this number represents, kind of look the same than this one. So that's why it's so much important. CITR, it's so much important, and knowing what is a bit, what is a byte, it's also very, very important. It's because of this, guys. Because like that, you could say, okay, an IP address have 4 bytes. Each byte is 8 bits. It says here 24. So it means that the first byte here, the first byte is covered by the network address. Sorry, network address. I just want to wipe. Oh, okay, it's fine. The network address is covered here, but hold on. The first portion, 1 byte, 8 bits. Second portion, 8 bytes, 8 bits, sorry. So 16. Third byte, another 8 bits, so 24. So what I'm gonna say in my head, okay, I stop here because this is where it's located. This is where the network address live. Then here, what is it? You are actually giving this part to the host, to us. devices employee. You're giving this port to your employee. So the DHCP, when it's going to deliver all the new IP address, he's gonna give this port. So this one is the where your network address live, but here you are letting this to your host. Okay, so when we say 24, we are actually leaving 8 bits for the host. So for us, for the employee, for the devices, the laptop, your phone, IoT, Internet of Things, we are giving all of these things here, okay? And what does it mean? You have 256 combination. So it means that you could add up to 256 devices. So if you have, for example, 30 employees, you have 30 employees, multiply by 5, because imagine they have a laptop, one have 2 phones, and we could say that, for example, you have many IoT. Okay, you have many IoT, many small devices that are linked to like, let's say, security camera, you know, all of these things. So it means approximately per user we have 5 devices. So it means you have 500. So it's still okay. So if you are in a site with 30 people, you have and they all have an average of 5 devices, it means that you have 150 sorry, you have 150 devices that are registered to the network. Okay, and what left? How many left you got? I'm gonna let you do the math, but it will be 106, right? 106, yeah, because it's 256. Yes, I'm right. But no, I'm making a mistake. It's 5. You see, I made the mistake. Maybe I did it on purpose, so you could figure it out and learn better. Because it's really with this kind of mistake that you could learn better. So yeah, so it's 105, not 106 that is left, because we count the 0. But actually, I didn't say it. I actually didn't say it, because I say 150 device. So okay, let's do it the good way. Okay, even though it's not planned, 150 device register in this network. In my network, for example, I have a site, and in my Paris site, I have 150 devices. What will be the number here? On the host number, what will be the host number? The host number will be 150 or 49. Yes, it's going to be 149, because we count the 0. Okay, and then it's actually, even this is not really true, because you have like places for the network, places for this, but it's just a way for understanding that it's just a way to understand that the 0 counts. So it means that you could then add 156, right? You could still add 106 devices, because you will reach then this plus 149 plus 106, it's 255. Okay, so guys, this one it's really important. I'm telling you, this what I just covered right now, to understand networking, it's so much important. I was about to go to another subject, but I just realized that we need to cover another very important things. And this important things is IP subnets. Did I told you that the IP address that you see here is perceived for VMware as a subnet. I don't know if I told you this. Sorry, it's a long life. It's very long life. So I kind of forget. But let me. I'm sorry. I'm starting to forget. Okay. So here, Imajan, we live in a very in a real company's environment. This is the network address. It's where the network address is located, right? It's where the network address is located. So we need also to talk about a very important stuff, which is IP subnet, because in most company, network is divided into small portion, and they do this for efficiency, like efficiency of IP efficiency, IP management. It's how we call it. So it's to avoid first wasting IP addresses, and also to reduce congestion. So it limits broadcast traffic to this within the subnets. Okay, and also they do it for security, because if, for example, you have the marketing team located here, IT team located here, it's very important. So what is IP subnet? And like I told you, IP subnet it's an important notion. So IP subnet and you have also subnet mask. But do I want to talk about that or not? Um, mm, mm, mm. No, it's okay. I could touch on it just a little bit, very a little bit. Okay, so what about IP subnets? IP subnet, it's a way, like I told you, to divide your network. Guys, I'm just going to give one example and that's it, because it's the only thing you need to know. You have here my network. Here it's my network. We have, I said, 256 combination, right? Let's say I have only two. I have in my network, I only have two departments. Okay, I only have two departments. The first department, the first OU, let's say the first OU, organizational unit, is sales. Okay, and this one product. So the one that do the product and the one that sells the product. Okay, so very, very simple company structure. So we want to keep things secure, efficient, and reduce congestion. So the sales team have a very good subnet that go fast, etc. A very good network that go fast. Same for the product team. I would say it's it's very important for the product team to have a subnet. So what we are doing is that we are actually splitting the IP subnet. So this is the work of the network engineer. So we will just cover what you will see, like when the network engineer will come to you and will talk to you about what's going on in the subnet and what is the network topology. We will see this later, which means how your network is structured. He will tell you this. Okay, he will show you that 192.68.57 57 slash, sorry guys, 0, if I'm not mistaken, slash 25. Not anymore 24. Not anymore 24, but 25. Why? Why I'm doing 25 when splitting the network? And here I'm giving the other part of the network, which is this, and I'm doing the same, 25/25. I'm gonna let you think, but I kind of give it, right? I kind of give the answer. But you will see it's very interesting. I really love covering this. And it will be a perfect transition for network topology. So guys, when we say 25, we are I want to lock it. And this I want it to leave. So when we are mentioning 25 for the IP subnets, it's simply, again, it's all about bits, guys. All about that. Nothing less. How can I explain it the best way without too much like, I don't want to add too much information into this. I know that some of you already got it. So you have here 24, sorry. 24, when we do /24, it means that we are giving 8 bytes out of the 32. You know, we cover this here. We cover here. Here, you have no host. You have no host places. You have no room, sorry. You have no room for the host. So we are directly giving /32, like no room available. All the 4 bytes and the 32 bits are full. You have no place for anything. And why? Because it's the location of the device. It's the location of here my DC2, right? It's the location of my DC2. So here it means, it means that it's full. Now here, when we say 24 bits again, we leave 8 bits for the host. And what represent 8 bits? We just see this right now. It means 24 combination. It means 24 combination, okay? 24 combination. When we say /24 bits, how much we are giving to the host? Are we giving here, when I say host, guys, I mean this. What we are giving to the host? Are we giving 256? Are we giving 8? I don't know, like how much combination we are giving left to the host. So 25 minus 32 equals 7. 7 watts, 7 bits. How many 7 bits have for combination? Guys, we cover things here at the top. 7 bits have 128 combination. Why? Again, if you guys forget, you have here 7 bits, okay? 0 0 0 0 0 0 1 2 3 4 5 6 7, okay? And you want to find how much combination. So this then this, etc., etc., you would have 128 combination. So that's why, and when you have 6-bit, for example, if I'm only giving 6 bits to the host, which is here, okay, here, I'm only giving, if I'm giving 6 bits to the host, I'm giving, remember, 64. It's only 64 combination. So here I'm only giving 64 combination, which means 64 laptops. Okay? 64 devices, which could be everything, IoT, laptop, phones, etc., etc. So, okay, guys, I hope you get the answer. So I know that some of you, I had it many times with, I'm not gonna say the name, but um, when they think about going from 24, which is 256 combination, okay, it's fine. 26 combination, 240, what I just put? Yeah, sorry. 24 bits left, it means 256 combination because it's 8 bits, which is 1 big byte. And 1 big byte, again, it's 256 combination. Most of the people, when they don't have a proper understanding of what is a byte, a bit, etc., etc., they think that going from there to there, it's like there is many things. Some people could say that it's 148. Why? Why some people could think that it's 248? Because of 8 bytes. So they think that they should only divide it 8, subtract by 8 bytes. Again, here 26 subtract by 8 bytes. But it doesn't add up because when you will arrive to here, to 32, which means it's full, you will still have combination left. You will have, like, I'm just saying something randomly, like 220. So it means that you will have still 220, but how it's possible since 32, if you see slash 32, it means that it's the location for the host and there is no room for other host, which is normal. So guys, please look at this live every I would say every 2 weeks, every month. Go back here and yeah, just listen to what we said. Listen to what we said and what we covered here because it's a very important topics. And guys, in your whole career, you will heard about that. You will heard about where the network is, where the IP subnet is located. Now, what can I add more? Because I'm gonna go to um to place in my mind, and then I will forget the most important. Now, what is subnet mask? Okay, what is subnet mask? Subnet mask, it's actually uh hold on guys, I will simply do this. I will simply unlock again. And I told you guys it will be the most interesting topic that we did. Um, but how you can? Okay, I just block it again. So yeah, subnet mask. Don't worry, guys. I will keep my energy quite high until the end. So let me just fix my mic. Yep, sounds good. Okay, perfect. I'm just fixing my mic, guys. Okay, so what about now subnet mask? Okay, did I cover everything here on IP subnets? So as you can see here, if I could just cover like last time, the just like the last observation and notation concerning this, you have here one IP subnet that is located in cells, and you have another IP subnet that is part of the same big subnet, which is the one that we cover at the top. That is this one, I guess. Yeah, that is this one. And yeah, they both divided into two. So now what about subnet mask? So you are, let's say I'm just looking at the time. Mm, okay, so for the subnet mask, here it's our IP address, right? It's our IP subnet address. And again, on VMware, if you go to virtual editor, network editor, you will see that the IP subnet, it's the whole network, which is counterintuitive. Okay, I'm sorry, I don't know if I show you this or not, but you just go to virtual network editor and you will see that just at the bottom you will see IP subnet, and you will see like it's the place where you all network live. It's the network address. Okay, so here you have the network of the cells OU, which is 192, 168, 57.0, yeah, 0 slash 25. And here, so here we're going to talk about subnet mask. I'm going to add the subnet mask and you will maybe understand it directly or not. 255, 255, 255, and lastly 100. Sorry guys. Oh, okay. Okay, so it's perfect. It's perfect. I reached the limit and it's at the perfect moment. Guys, what could be the subnet mask? Try to be this smart as you can. Try to be the smart. Try to be the smartest. Yeah, the smartest as you can. Just try to be smart, guys. Try to be very smart and figure it out. And figure it out. That. Mm, okay. Actually, sorry. I can directly do this. I don't need all of them. So, for the one who who has a good thinking a good thinking method, it's actually it's actually going to be 100, and I'm gonna try to do this. Is going to be 100 again, 128, 128. Why? Because here we have consumed all the bytes. Okay, we have consumed all the 8 bits. So 255, like no room left. Here we have consumed everything, all the byte. So all the 8 bits, sorry, in little. So no more places, no more rooms. Here we have consumed everything. 1 byte, 8 bits, okay? And here we have consumed only the half. We have consumed only half of the network. So it means that we have um, another 7 bits left, okay? We have another 7 bits left. So it means that we have 128 28 combination left. So that's why here it's 128. It's think of subnets as the combination left. Okay? If for example my let's guys, okay, I just quit it, but imagine I don't have any IP subnets. Okay, imagine I don't have any IP subnets and my network is this. I'm gonna point another. I'm gonna create another IP address. So it's a new one, okay? 200, 500, 0, okay? And by the way, just for the new arrivals in case, 192 usually network address, local network address always start with 192.168. It's the standard. It always start with this. So yep, it always start with that. But here I'm just gonna make something like very different so you can see that it's a very different IP address. And my network address is this, okay? My network is this thing, okay? So it means that we are here 24 and I have 8 bits. Sorry, am I making a mistake? No. We have 8 bits left. So 255 256 combination, okay? 256 combination. What is the subnet mask of this? What is the subnet mask? What do you think? So here we have full. So it means that again, guys, we have 1 byte left, okay? 1 byte left here in this network. Here, oh, maybe I didn't say it, but it's very important. Guys, I forget to mention very important things. It's here. Think of it as the network portion, okay? This thing here is the network oh my god. You know what? It's fine. I'm not gonna it's fine for me. Um Here it's the network portion, okay? And here, guys, it's the actual host portion, okay? So here, let's go back to the subnet mask. To the subnet mask, here it's 255, okay? 255. Everything, like all the byte, is consumed by this portion here, by this small segment. Here, same. Everything, because we are in the network portion, so nothing left. Here again, 255. No room left. Here, same, 255. But here we have a whole byte left. So it means 0.0. Okay? It means that the subnet mask means that you could give 250, 56, 55, 250, sorry, 56 combination to this network. Okay? To this network. So yeah, guys, I hope that you could try, like, to see when you will create your lab environment, try to play with this and also notice what's going on. What is the subnet mask? What is this? What is that? Because most of the time when you go on YouTube and you see a tutorial for implementing your own VM, even the Udemy course, they don't explain this. Like the whole thing that I went with you, they don't explain this. They just directly say, yeah, put this, put 192, 168, 57.0, and then they just leave it there. But it's very important to have this concept in mind. So next time, try to play a little bit with it on your VMware, and if you have any question, anything, like, just tell me and I will help you out. Okay? So yeah, very very important topic, and don't hesitate to go back, on this live session to just have the right knowledge, just to put things in place, to put things in order. So guys, like I said, it will be the perfect transition for network topology.